So for today's lesson, we're going to continue practicing solving systems of equations by elimination. And this is page 263 in your Unit 2 book. All right. So we're going to solve each of these. All right. So remember, when you're solving a system of equation, the idea is to eliminate one of the variables by addition or subtraction so that you can focus on one variable, find the solution to that, and then use that solution to help you find the other variable. So as I look at this system, I notice that the coefficients for my x, okay, have the same absolute value, right? They both have a 2. So that makes it easier. But one is a positive 2 and one is a negative 2. So if I want that to be 0 x's, I'm going to have to add, because 2x plus negative 2x gives me 0, and that's what I need, right? I can't subtract, because if I subtract, I have 2x minus negative 2x, and that's 4x. And that's not what I need, because that doesn't help me eliminate a variable. So 2x plus negative 2x is 0, just like we want, okay? So this gives you 7y equals 21. We're going to solve for y, so we divide by 7 on both sides. Y equals 3, right? So if y is 3, go ahead and substitute 3 for y in either equation. And I'm going to do my first one, but it doesn't matter which one, okay? So that gives me 2x plus 9 equals 7. Go ahead and minus 9 from both sides. So 2x equals negative 2. Divide by 2, divide by 2, x is negative 1. Right? So my solution is going to be negative 1, 3. Now remember to check. See, okay? Check to see if that's correct. So I have 2, x is negative 1. So 2 times negative 1 plus, whoops, there's not a plus. So plus 3 times 3. Does that give me 7? Yes, it does, right? It needs to be correct for both equations, not just one. So 2 times negative 1, okay, plus 4 times 3. And that gives me 14. So, okay, I know I'm correct. All right, so y, okay, the coefficient of the y variables, okay, have the same absolute value. One is a positive 3, one's a negative 3. So I'm going to add. Once again, they're opposites, so I add so that I can eliminate the y. So that gives me 5x equals 10. I'm going to need to divide by 5 on both sides. So x is equal to 2. If x is 2, okay, go ahead and substitute, okay, into either equation. So that gives you 4 plus 3y equals 7. Minus 4 from both sides. So 3y equals 3. Divide by 3, divide by 3, y equals 1. Okay? So remember, you can check by substituting x and y into both equations and seeing if you get true statements, or you could graph them and see if those two linear equations intersect at this point. the next problem. Right? X seems to be the variable we should eliminate. And since they're the same, in order for me to get 0 from 2 and 2, I'm going to have to subtract. So 2x minus 2x is 0, right? 3 minus 4 is negative 1y. And 5 minus 9 is negative 4, right? Y is equal to 4. If y is 4, I'm going to go ahead and substitute. So let's do 2x plus 4 times 4 equals 9. So 2x plus 16 equals 9. If I minus 16 from both sides, 2x equals negative 7. Divide by 2, right? X is going to be equal to negative 3.5. So my solution is negative 3.54. Right? Now, let's take a look at D. D is different in that none of the coefficients, right? So neither the coefficient for X, so the coefficient for the X's are 2 and 6, or the Y, which is 3 and negative 5. And neither of those coefficients have or has the same absolute value, right? They don't have the same numbers. So what can we do? Because we need them to have the same number so we can eliminate. Okay, we need the coefficients to have the same absolute value so we can eliminate by addition or subtraction. But I'm noticing and I look and I'm like, well, if I multiply 2 by 3, I will get 6, right? And I told you before that I prefer to add whenever possible because we tend to make more errors when we subtract. So I'm going to go ahead and multiply this by negative 3. Now, in order for me to have an equivalent equation, I'm going to have to multiply everything in this equation by negative 3. Right? So that gives me negative 3 times 2x is negative 6x. Negative 3 times negative 3y is minus 9y. And negative 3 times 16 is negative 48. Right? So if I graphed this equation right here, negative 6x minus 9y equals negative 48. Okay? And I graph 2x plus 3y equals 16, you would get the exact same line. They're equivalent because I multiplied by the same number. Okay, I multiplied all elements of the equation by the same number. So they're equivalent. So that's fine. So this, I'm using this in place of that because it's equivalent. So now I go ahead and I rewrite my original second equation, and there's no need to go ahead and multiply that, right? So now I solve my problem. They both x's have the same absolute value. They're opposite, so I'm going to add to eliminate the x. So negative 9y plus negative 5y is negative 14y. And negative 48 plus 20 is negative 28. I'm going to go ahead and divide by negative 14, divide by negative 14. So y is 2. Okay? If y is 2, substitute. So 2x plus 3 times 2 equals 16. So 2x plus 6 equals 16. minus 6 from both sides. So 2x is equal to 10. Divide by 2, divide by 2, x is 5. Right? So my solution is 5, 2.